Hi, my dear students. All of you are well experienced with the four basic operations, that is addition, subtraction, multiplication and division of polynomials. In today's session, we are going to see a new topic on polynomials, which is based on the division. Again, I welcome you all to your own channel, Noble Mathematics will find a way or make one. Our today's topic is division algorithm for polynomials. Just like the division algorithm for real numbers, we have a division algorithm for polynomials also. If p of x is any polynomial divided by another polynomial g of x which is not equal to 0, then we can find two other polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x may be equal to 0 or degree of r of x is less than degree of g of x. The statement is, if a polynomial p of x is divided by a polynomial g of x in which g of x is not equal to 0, then we can find two polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x is equal to 0 or degree of r of x is less than degree of g of x. Here q of x is the quotient polynomial and r of x is the remainder polynomial. P of x can be considered as the dividend polynomial and g of x is the divisor polynomial. So here we have a p of x is equal to g of x into q of x plus r of x means dividend polynomial is equal to divisor polynomial into quotient polynomial plus remainder polynomial, where remainder polynomial can be equal to 0 or degree of the remainder polynomial is always less than the degree of the divisor polynomial. This is the statement of a division algorithm for polynomials. Let us illustrate this division algorithm for polynomials through an example. Let p of x is equal to 3x square minus x cube minus 3x plus 5 and g of x is equal to x minus 1 minus x square. So here p of x is the dividend polynomial and g of x is the divisor polynomial. You can clearly observe this polynomial, the powers of x are not written in the descending order, and here also the powers of x are not in the descending order. Doesn't matter, but when you divide, you have to write the powers of x in the descending order. Here the first step is to divide the p of x, that is the dividend polynomial, by g of x. When you write p of x, make sure that the powers of the variable x are in the descending order. So I write minus x cube first plus 3x square minus 3x plus 5. Here the dividend is minus x square plus x minus 1. Here also I have written the powers of the variable x in the descending order. And here you will get the quotient. You know the division procedure for polynomials. Here we divide the first term, that is minus x cube, by the first term of the divisor minus x square. minus minus will be plus, x cube by x square. X cube by x square, you will get x, and that we write in the quotient part. The next step is to multiply this x with each term of the divisor and write down the various terms of the dividend. X into x square, that is minus x square, we get minus x cube. So I write this term under x cube. X into plus x, that is plus x square, that I write under x square. X into minus 1, that is minus 1x, that I write under x. The next step is to subtract. While subtracting this expression from the upper expression, definitely the signs will change. Minus will become plus, plus will become minus, and minus will become plus. As a result, minus x cube plus x cube is 0. Generally, whenever you do the division of polynomials, the first terms will get cancelled. Then 3 minus 1, 3x square minus 1x square, you get 2x square. Minus 3 plus 1, minus 3 plus 1 is minus 2x, and this 5 is bringing down, that is plus 5. The next step is to divide the first term of this expression by the first term of the divisor. That is 2x square divided by minus x square. X square and x square will get cancelled. 2 and this minus sign, we get a minus 2 here. The next step is to multiply this minus 2 with each term of the divisor and write under this expression. Minus 2 into minus x square, that is plus 2x square. Minus 2 into plus x, that is a minus 2x. Minus 2 into minus 1, that is plus 2. The next is to subtract this expression from this one. The signs will change. 2x square minus 2x square get cancelled. Minus 2x plus 2x, that also get cancelled. Minus 2 plus 2 is 0, that is why these two terms also gets cancelled. 5 minus 2, that is 3. Now here the division ends. Because this is a constant polynomial, the degree of the constant polynomial is 0. You cannot divide a constant polynomial by a quadratic polynomial. So here the division ends with a quotient polynomial, that is q of x is equal to x minus 2. And the remainder r of x is equal to 3. Here q of x is equal to x minus 2 and r of x is equal to 3. Here you can clearly observe that the remainder polynomial is 3, which is a constant polynomial whose degree is 0. According to the condition of the division algorithm, the degree of the remainder polynomial, that is r of x, should be always less than the degree of the divisor polynomial g of x. Here the degree of the divisor polynomial is 2, degree of the remainder polynomial is 0, so that condition is satisfied. So we have a q of x is equal to x minus 2, r of x is equal to 3. The next is to verify the division algorithm. For that, we take the RHS of the division algorithm statement, that is q of x. That is g of x into q of x, both are same, plus r of x. We are going to multiply g of x and q of x, then we add the remainder polynomial r of x is equal to, what is g of x? That is x minus 1 minus x square into, what is q of x? X minus 2 plus r of x is 3. X into x we get x square x into minus 1, that is minus x. X into minus x square, that is minus x cube. Then minus 2 into x, minus 2x. Minus 2 into minus 1, that is plus 2. Minus 2 into minus x square, that is 2x square. Then plus 3 is equal to x square plus 2x square, that is 3x square, minus x cube, minus x minus 2x minus 3x, 2 plus 3, that is plus 5. 3x x square minus x cube minus 3x plus 5. 3x square minus x cube minus 3x plus 5, which is the dividend polynomial. So you can write this is equal to p of x. That is g of x into q of x plus r of x is equal to p of x. Therefore, the division algorithm is verified. That is p of x is equal to g of x into q of x plus r of x. Therefore, verified. So what we have done? We were given two polynomials p of x and g of x. We divided p of x by g of x and we got the quotient polynomial q of x is x minus 2 and the remainder polynomial r of x is equal to 3. And then we verified the division algorithm by multiplying g of x into q of x plus r of x. After substituting the values of the g of x, q of x and r of x, we simplified and we got the polynomial which is equal to p of x. Hence, the division algorithm is verified. Let us do a question based on the division algorithm for polynomials. The question is, check whether x square minus 3x plus 1 is a factor of x raised to 5 minus 4x cube plus x square plus 3x plus 1. Here, the dividend polynomial is x raised to 5 minus 4x cube plus x square plus 3x plus 1 and the divisor polynomial is x square minus 3x plus 1. So, p of x is this polynomial and g of x is this polynomial, that is x square minus 3x plus 1. We will divide p of x by g of x and we will get a quotient and the remainder. If the remainder polynomial is equal to 0, then this is a factor of this polynomial. If the remainder polynomial is not equal to 0, then x square minus 3x plus 1 is not a factor of x raised to 5 minus 4x cube plus x square plus 3x plus 1. So, we are going to divide the dividend polynomial by the divisor polynomial to get the quotient and remainder. Let p of x is equal to x raised to 5 minus 4x cube plus x square plus 3x plus 1 and g of x is equal to x square minus 3x plus 1. Dividing p of x by g of x. When you write the polynomial p of x, you can see x raised to 5 minus 4x cube. One term is missing. X raised to 4 term is missing. So when you write this polynomial for division procedure, you write 0x raised to 4 to fill that place. That is, we will write the dividend polynomial like this. X raised to 5 plus 0x raised to 4 minus 4x cube plus x square plus 3x plus 1 divided by divisor polynomial is x square minus 3x plus 1 and here you write the quotient. The division procedure is same, that is first term by first term. X raised to 5 by x square. X raised to 5 by x square, you get x cube. That you write in the quotient part. Now you multiply this x cube with each term of the divisor and write down the different terms of the dividend. X cube into x square, that is x raised to 5. I write under x raised to 5 term. X cube into minus 3x, that is minus 3x raised to 4. X cube into plus 1, that is plus 1x cube. The next step is subtraction. While subtracting, the sign will change. This will become minus, this becomes plus, this becomes minus. X raised to 5 minus x raised to 5, 0. Now 0 plus 3, that is 3x raised to 4. Minus 4 minus 1, that is minus 5x raised to 3. Then we write this all terms down, that is plus x square plus 3x plus 1. Now the first term is 3x raised to 4. So 3x raised to 4 by the first term x square. X raised to 4 and x square will be cancelled. You will get x square. So the quotient part, we will have a 3x square. 3x square into x square, that is 3x raised to 4. 3x square to minus 3, that is minus 9x cube. 3x square into plus 1, that is plus 3x square. Now we subtract. For subtraction, you know the signs will change. This is minus, this becomes plus, this becomes minus. 3x raised to 4 minus 3x raised to 4 will be 0. So these two terms get cancelled. Minus 5 plus 9 is 4x cube. 1x square minus 3x square is minus 2x square. I write these terms again down, 3x plus 1. Now the first term is 4x cube by first term x square. X cube and x square get cancelled. We get 4x. So I write 4x here. Now 4x into x square, that is 4x cube. 4x into minus 3, that is minus 12x square. 4x into plus 1, that is plus 4x. What is next? To subtract. When you subtract, the sign will change. Minus, plus, minus. Now 4x cube minus 4x cube will be 0. Next, minus 2x square plus 12x square. Minus 2 plus 12 is 10x square. 3 minus 4 is minus 1x plus 1. Now, again we have to divide the first term by the first term. 10x square by x square, you will get a plus 10. Now, 10 into x square, that is 10x square. 10 into minus 3, that is minus 30x. 10 into plus 1, that is plus 10. Again we subtract. When we subtract, the sign will change. 10x square minus 10x square will get cancelled. Minus 1 plus 30. Minus 1 plus 30 is 29x. 1 minus 10 is minus 9. Here 29x minus 9 is a linear polynomial whose degree is 1. The divisor polynomial is x square minus 3x plus 1 whose degree is 2. Now the division ends here. So here the quotient polynomial is x cube plus 3x square plus 4x plus 10, and remainder polynomial r of x is equal to 29x minus 9. You can see the remainder polynomial r of x is not equal to 0. Since r of x is not equal to 0, we can conclude that x square minus 3x plus 1 is not a factor. The remainder is not equal to 0, therefore the divisor is not a factor of the dividend. If the remainder is equal to 0, then the divisor will become a factor of the dividend. So this is how we used the division algorithm to check whether x square minus 3x plus 1 is a factor of x raised to 5 minus 4x cubed plus x square plus 3x plus 1. I hope all of you understood what is a division algorithm for polynomials and how to verify the division algorithm for polynomials. Also, we have done a question based on the division algorithm for polynomials to check whether a given polynomial is a factor of another polynomial. That is all for today. We will meet in the next class with some new questions based on division algorithm for polynomials.